Okay, so in this video, we're going to create a graph from a description. So it says Sam went on a bike. He accelerates to a speed of 20 kilometers per hour. So we're going to assume that this acceleration starts from 0, right? Because at one point in time, he was going to be not moving, and then he starts moving. So starts from 0 kilometers per hour. He then drives at this speed, so the 20 kilometers per hour, for 30 minutes. Okay, at the bottom of the hill, the speed drops to 5 kilometers per hour for another 10 minutes. As he climbs back up the next hill, he stops at the top of the hill for 10 minutes. Okay, so sketch a graph of speed as a function of time. So when we say as a function of this over here, that means it's the dependent variable, which means that it's going to be on the y-axis. So what I'm going to do is I'm going to label this here. This is going to be the speed, and it's going to be, oops, I wrote speak by mistake. Let's just erase that and put speed. And that's in kilometers per hour. And then that means that time is the independent variable, or it goes on the x-axis. And that's going to be in minutes, simply because they just give us minutes as units inside the question. So we're going to write minutes here. Okay. Now, again, how do I know that something is the dependent or the independent variable? Well, whether you move or not, time just continues to tick, right? So that means it's not actually dependent on speed. Now, the speed units is kilometers over hours. It literally depends on the amount of time that passes, right, as part of its calculation. So that makes it the dependent variable, right? So you often just stop and think about, quickly, well, what does 1 unit require? And that's how we kind of figure out if it's the dependent or independent variable. So what we're going to say is, now, one part I don't like about this question is that it says he accelerates to a speed of 20 kilometers per hour, but it doesn't actually tell you when. You don't go from just 0 all the way to 20 in no span of time. So we're going to say, in 5 minutes. Okay, so it'll take, it won't actually take that long. Actually, let's make that a bit shorter. Then let's just say in 1 minute. So I would say that this question is a little bit incomplete because it should take about 1 minute to actually do that. So I'm going to make a point starting at 0 because he goes at no speed. And then at about 1 minute, so let's say it's about here. We're going to plot our first point here. And that's going to be at 20. Then it says it goes at that speed for 30 minutes. So from that 1 minute, I'm going to go all the way to about 30 minutes. Now, if it's 30 minutes from that time, I'm going to go a little bit over, so like 31 minutes. So here it is. And again, I just drew a straight line because you're going at that speed of 20 for 30 minutes. Then you're going to drop to 5 kilometers per hour for another 10 minutes. Now, here's the thing. You can't just all of a sudden drop. But if we are going to follow what the graph says, then we drop straight down, right, to 5, and you're going to remain there for about 10 minutes. So all the way down to just over the 40. Okay? And so I could connect these two here. And then it says that climbs that back up the next hill. He stops at the top of the hill for 10 minutes. Okay, so then we're going to assume that if he stops at the top of the hill, the stopping is 0 kilometers per hour. So, again, it's not that realistic, but I would kind of just drop all the way to 0. And then for the next 10 minutes, just go at 0 kilometers per hour. Again, I think probably in the video, they made it like a little bit slanted, like they did something like, and I'll just draw it in black, something like this. And that's probably more accurate, but the problem is you have to tell us at what rate it's actually doing that at, and they don't say that. So based on the information given us, we're just going to go with the original where it's just dropping. Okay. And this is the graph. Okay, so for this video, we're going to show you how to graph functions in y-intercept form. And when we're talking about y-intercept form, we're pertaining to this equation, or I should say we're referring to this equation. So this is the slope y-intercept equation. The b is the y-intercept, and that's where the graph crosses the y-axis. And then the m is the slope. And if you're coming from earlier maths, you would have probably recognized this as the rise over the run. And that's also known as the change in y over the change in x values. Okay, so let's say we're asked to graph this equation here. Y is equal to 1 over 3x plus 1. This is the y-intercept, or the b value. So that's going to be where the graph crosses the y-axis. And then here is the slope, where the rise is going to be 1, and then the run is going to be 3. So the first thing we're going to do is we're going to plot the y-intercept first. So that's at y is equal to 1. And the y-intercept is also always at x equals 0, right? Because that's where it's going to actually cross the y-axis when x equals 0. So we're going to put a point, and I'll do it in red here, at the 1, the 0 and the 1. Okay, so that's the y-intercept. Okay, the next thing we're going to do is from the y-intercept, we're going to plot 3 points using the slope. So I'm going to start at the y-intercept, and I'm going to go up by 1 over here, and then over by 3. And that's where I'm going to plot this point here. And then I'm going to do the same thing for the other one, up by 1, over by 3. Right? And every time it's the same thing. So remember, that's 1 and that's 3. And then I'm going to do one more point, up by 1, over by 3. And I mean, I know it kind of goes off the graph here. We don't have to, I could extend the line. And it's going to continue that way anyway. Okay, and then I'm going to connect the points that I've drawn here. And then that is our equation. So this is the graph for that equation here. So just a simple 3-step process. And if you do this consistently every time, you're going to be able to graph these no matter what, coefficients or variables we give you.